Now look at the problems we have for mole concept, right? So first of all, you should be familiar with few formulas. So first formula what I am telling you is, if you need to find mole of any substance, whether it is an atom or whether it is a molecule, so what is the formula for mole, calculating the mole? Mole is given mass over atomic mass. And if it is molecule, so it becomes molecular mass. Suppose I tell you that suppose I have a question for you. Suppose I ask you that how many moles are there in 3 grams of oxygen atom. So what term I am asking you? I am asking you to calculate the moles in 3 grams. So that 3 is going to be the given mass. That means the mass which is given in the question, right? And again I repeat the question. How many moles are present in 3 grams of oxygen atom? So 3 is going to be given mass, and the atomic mass for O is going to be the atomic mass, right? But if it is a molecule, like if I ask you how many moles are there in 3 grams of oxygen molecule, that is O2, then again 3 gram is going to be given mass, and instead of using atomic mass, we will be using the molecular mass, that is the mass for O2, that is 16 into 2, 32, right? So likewise we will be taking up the problems, and in each and every problem I will just tell you the formula which is used. So just write the types of formula which I am using in different problems in your copies with one example each, so that when you will go through that copy again, you will have an idea that what kind of formulas or what kind of problems you can encounter in paper. So first question is this: how many moles are there in 160 gram? So 160 gram, as I told you, we need to find moles in 160 gram. So obviously it is going to be our given mass, right? Of NaOH. So this is atom or a molecule? Obviously it is a molecule. So we will be having a molecular mass for it. So I am just writing the formula first. So we have mole is equal to given mass over molecular mass, because it is a molecule, right? So putting values in formula, what is given mass? It is 160. And what is molecular mass? We need to calculate. So I am just calculating here. We need to use atomic mass for calculating molecular mass, you know that, right? So Na atomic mass is 23, oxygen atomic mass is 16, hydrogen atomic mass is 1. Sometimes you will be given with the atomic mass, and you just need to you can say add the values accordingly present, the number of atoms present in a molecule, but try to remember the atomic masses as well, right? Because see, in chemistry you are going to study the same elements again and again, so it is better to have an idea of the atomic mass instead of waiting for your teacher to give you atomic masses, right? So as you know that the atomic mass of sodium is 23, oxygen is 16 and hydrogen is 1, because one atom each is present, so I have just added it, right? So what what result I am going to get? 23 plus 17, that is 40 grams, right? So this is my molecular mass. So I have put here, cancelling 0, so what we get? We get 4 moles. So this is how you are going to find the moles. See, I have just summed up different kinds of you can say questions for you, so that you should know that what kind of question you can get in paper. So if somebody asks you to find number of moles and you are given with the given mass and you have the formula whether it is of atom or a molecule, you need to do like in this way. Now the second question, what is the mass in grams? So you need to find the mass, right? Because here we found moles, and here the question is asking to find mass in grams of 2.5 moles. So you are already given with the moles of this compound. Obviously it is not an atom, you know that CaOH whole twice is calcium hydroxide, that means it is a molecule. So we need to have molecular mass. So what formula you are going to use here? Obviously the same formula we are going to use here, that is mole is equal to given mass over molecular mass. So you are provided with this and this, you have to find this. So we can easily do, right? So just I am writing the formula first. Mole is equal to given mass over molecular mass, right? So I need to find this. So I have given mass is equal to mole into molecular mass. So how many moles we have? We have 2.5 moles. What is the molecular mass? Again I have to count. So what is the atomic mass? I am just writing for you. Calcium atomic mass is 40, oxygen is 16, hydrogen is 1. So we are just adding them accordingly the number of atoms which are present in it. So what we have 40 because there is one atom, so one mass of one atom of calcium is 40, plus because Ca and O are two different atoms. So how many O? 2. Mass of one O is 16. So mass of 2 O is 2 into 16. Again plus how many hydrogens we have? Again 2, and mass of one hydrogen is 1. So after just solving it, what we get? 40 plus 32 plus 2, 40 plus 34. So it comes out to be 74. So this is what we are going to put here. So after solving, we get the desired result. So this is how you are going to calculate the mass when you are given with the moles, and the question is asking you for the mass, so you need to do in this way, right? Now look at the third question. In what you have to find in this question, we need to calculate mass of one atom of O, right, and calculate mass of one molecule of O. Before we start this question, I am just making you remember that point which we did in a molar mass. What is molar mass? Molar mass is mass of one mole. You know that the molar mass is actually equal to the atomic mass, or it is equal to the molecular mass in case of molecule. You know that, right? So how many number of molecules just make a mass of mass corresponding to atomic mass or the molecular mass? It is not the one. I told you that it is actually the mass of one mole. That means 6.022 into 10 raised to power 23, right? So likewise we will be doing here. So now if if you are given in the question that the atomic mass of oxygen is 16, and here you need to find the mass of one atom of O, and here you need to find mass of one molecule of O. Molecule of O is O2, so that is why it is O2. Now we know that mass of one mole of atom is equal to the atomic mass. This we did in molar mass. You know that the mass of one mole is equal to the atomic mass, because here I have to find for mass for the one atom. That is why I am taking atomic mass. So that means mass of one mole of atom is equal to the atomic mass. So how many atoms? 6.022 into 10 raised to power 23 atoms weigh. What is the atomic mass for oxygen? 16. So it weighs 16 grams. So what is the mass of one atom? So mass of one atom, if this much weighs this, so obviously one mass of one atom weighs, you have to divide it, right? So what answer you are going to get? You are going to get, after just solving, 2.6 into 10 raised to power minus 23 grams, right? So this is the mass of, actually the mass of one atom. So I'll just sum up the formula above. So if you need to, if somebody asks you to find mass of one atom or mass of one molecule, what formula directly you will be using? You will be using atomic mass divided by Avogadro number, or if it is molecule, then molecular mass again divided by Avogadro number, right? So see, you can just cram the formulas also, right? But here our motive is that you should understand thoroughly, and then you may pick the formula direct and use it direct, but you should know the logic behind, what is the logic behind why we are using it, or because I may have told you that just use this formula, right? But instead of telling you to cram this thing, I want you to know actually, so that you should know the mole concept in deep, right? So this is what you need to remember. Now similarly we have to calculate the mass of one molecule of O2. So you know that the 6.022 into 10 raised to power 23 molecules weighs how much? So 6.022 into 10 raised to power 23 molecules weighs actually equal to molecular mass. So what is the molecular mass for it? 16 into 2, 32, because this molecule contains two atoms, right? So molecular mass is going to be 16 into 2, 32. So it weighs 32 grams. So what is the mass of one molecule? It is equal to 32 divided by 6.022 into 10 raised to power 23, and what is the result? We have 5.3 into 10 raised to power minus 23 grams. Right, I am just writing the answer direct, because just to avoid you can say, because you know how to calculate, how to do multiplication and division as you are doing from the, you can say, many years, from last many years, right? So I am just calculating the value and just writing the answer here. I hope you know how to calculate the values, right? So this is 5.3 into 10 raised to power minus 23 grams. Now what is the other question we have? We have how many moles of S and O atoms are there in 1 mole each of this. That means I am taking one example. Suppose I am taking the first question part, that is H2SO4, right? So what this question is asking? It is saying we need to calculate moles of S and moles of O. So does it possess S and O? Yes, it possesses S and O, right? So we need to calculate moles of S, likewise we need to calculate moles of O. And what we are provided with? We are provided that we have 1 mole of this. So that means we have 1 mole of H2SO4 and we need to calculate moles of S in it and we need to calculate moles of O in it. And as you all know that mole signifies the same number, that is the Avogadro number. So that means if I ask you, like if I say 1 mole of carbon, so how many carbon atoms will be there? Obviously it will equal to the Avogadro number. If I say 1 mole of oxygen atom, so how many atoms are going to be there? Again it will be equal to the 6.023 into 10 to the power 23 number, because a mole means the same, right? So here what we have 1 mole of H2SO4. So how many atoms do you get to see in this 1 mole of H2SO4? Or you can say in one molecule, how many S you get to see? We get to see only one S. See, here is only one S present. So that means when there will be 1 mole of H2SO4, so how many moles of S is going to be present? 1 mole of S is going to be present. And if I talk of O, so how many O are present in this 1 mole of H2SO4? So again you need to you see 4 atoms. So obviously if we talk in terms of moles, so obviously how many moles are going to present? Again the 4 moles. So likewise you need to calculate, because mole actually means the same irrespective of the nature of the substance which we consider. Mole is actually the same term, right? So likewise we have another example, another quantity asked for the same thing. We have 1 mole of H2SO3. 1 mole of H2SO3. So how many in this molecule, how many S do you get to see? We get to see only one S. Right. So if I talk of 1 mole, if I say 1 mole of H2SO3, so how many S is going to be present? Again the same, that is the 1 mole of S. And if I ask you for O, so how many O is present in this one molecule? So obviously the atoms are present in this one molecule? 3 atoms. So that means 1 mole is going to have how many O? It will have 3 moles. So it will have 3 moles of O. Likewise we have third more part, SO2. So how many, if I again say we have 1 mole of SO2, so how many S you get to see in this one molecule? 1 S. So that means 1 mole will also have 1 S. So that means 1 mole of S. And O, one molecule has 2 O. So obviously if I talk about 1 mole, so obviously it is going to be 2 moles. So this is how you need to answer these questions in the same way. We are not limited to only these types, we have few more types. Now I am taking up the another type, just look at the